Hi students, I am Mr. Peng. Today I would like to discuss with you SPM format question about Chapter 4 Heats, Section 4.2, Specific Heat Capacity. Let's go. The question I selected for today's discussion is from the module Chem Square 2021. So let's discuss the question from section A, paper 2 first, okay? So let us read the question together. So diagram 1.1 shows two similar metal balls are heated for several minutes in boiling water. So the two metal balls were then transferred into two bigger fluids containing liquid X and liquid Y. Okay, so you can see the diagram 1.1. okay, so both the metal balls is heated together. So we expected the final temperature for the metal ball is the same. Okay, and look at the diagram 1.2. okay, so they is showing the initial temperature and final temperature of the thermometer in liquid X and Y. So you may see that in the diagram 1.2, the liquid X initial temperature is 25. There is same temperature with the liquid Y, which is also 25 degrees Celsius. However, the final temperature for the liquid X is higher, which is 40 degrees Celsius, and the liquid Y is about 30 degrees Celsius. Okay, so as we learned in the previous video clip regarding the section 4.2 specific heat capacity, in your mind you may know that for the material which showing the higher changes of temperature, that means the material will have smaller specific heat capacity. Okay, or we can guess the material will be a good heat conductor. Okay, and on the other hand, if the material showing small changes of the temperature, so that means the material will have a higher specific heat capacity. So it will be a insulator, a poor heat conductor. Okay, so let us continue read the question. So table 1 shows the specific mass and the heat capacity, okay, of the material X and Y. So from here, both objects also have the same mass, and the specific capacity for Y is greater than liquid X. Okay, so what is the meaning of specific heat capacity? So specific heat capacity is the heat required by 1 kg substance to increase about 1 degree Celsius. Okay, so this is the answer. Heat energy needed to change temperature of 1 kg substance for 1 degree Celsius. In this question, mention specific heat capacity, so you must mention 1 kg substance in your definition. Okay, so for the second question B, state the physical quantity that measured by thermometer. So what is the function for thermometer? Measuring temperature, right? Okay, so the physical quantity to be measured by thermometer will be temperature. Okay, so go for C. Based on diagram 1.2 and 1.3, compare the specific heat capacity of liquid X and liquid Y. Okay, so this is the first question for C. So the question asking us to compare the specific capacity. So we can look at the table actually. You see table? Okay, so the table showing that the specific heat capacity for liquid Y is greater than X. Okay? Okay, so you may see the answer for C1 will be specific heat capacity for Y is greater than specific heat capacity of X. You may using the symbol greater than. So the second question for C asks us to compare the final temperature of the thermometer X and Y. So for this type of question, is quite straightforward. You can just observe the diagram. So now we want to see which temperature is higher, X or Y. Final temperature. Okay, so look at the figure 1.2. The final temperature for liquid X 40 and the liquid Y is 30. So that means the final temperature for liquid X is greater than or higher than Y. Okay, so final temperature of thermometer in X is greater than final temperature of thermometer in Y. So C3, compare the changes of X and Y. Okay, so we can go back to the figure, the changes of temperature. So look at the liquid X, the final is 40, initial is 25. So 40 minus 25, we get 15 degrees Celsius changes. So for Y will be from 25 to 30. So the changes is about 5 degrees Celsius for liquid Y. So that means the changes of temperature for liquid X is greater than Y. Okay, so change of temperature in liquid X is greater than change of temperature in liquid Y. Okay, so the question for C4, state the relationship between specific capacity and the changes of temperature. Okay, so this one you can compare the question C1, which is comparison regarding the specific capacity between X and Y, and the third question, which comparing the temperature changes. Okay, so at here you may see that specific heat capacity Y, which is higher, will showing smaller changes of the temperature. Okay, on the other hand, if we choose material X, which has a smaller specific heat capacity, it will given a larger changes. Okay, so you can write in 2n. So the higher the specific heat capacity, the smaller the change of temperature. So this one is referring to liquid Y. Okay, so or you can write as the lower the specific heat capacity, okay, which is referring to X, which will showing bigger changes of the temperature. Okay, so we go to question D1. Which liquid is more suitable used as a coolant in a car cooling system? So for choosing the material as a coolant agent, so the coolant agent must be able to absorb more heat with not showing higher changes of temperature. So that means we need to choose bigger value of specific heat capacity. So at here we need to choose material Y. Okay, we choose liquid Y. The reason is Y has a higher specific heat capacity, which will showing slower rate of increasing of temperature. Okay, so heat slow, change of temperature in liquid is smaller. Okay, so this is the answer. Okay, so now we go to section A also. Okay, so this is another type of question tested you to select the correct material for the condition given. Okay, so at here the table 2 showing 3 types of paints and their characteristics. Okay, so here we got copper, we got aluminium. Okay, so they have the different value of specific capacity. So you can see the first one has a lower specific capacity, so that means the temperature changes will be expected higher, compared to another two. So the first question asks us to give the meanings of specific heat capacity. So this is the same definition in question 1, right? So this one we will discuss the heat required to increase the substance with 1 kg by increasing 1 degree Celsius. So the answer, heat energy is needed to change temperature of 1 kg substance for 1 degree Celsius. So now let us read together the question B. So based on table 2, state the suitable characteristic of pan if it is used to fry fish cracker faster. Give reason for the suitability of the material. So here we need to choose a material which can heat up quickly, heat up faster. So we need to select the material with lower specific heat capacity. So here the lowest specific heat capacity will be copper. The value is 387. So we need to select copper. So why? Because copper can heat up quickly. Heat easy to get hot. So because it has the lower specific capacity, good heat conductor, and able to absorb heat at a faster rate. So here the question is 2 marks. 1 mark given for selection material, and another mark will be give for the correct reason. You just need to select one of the reason. So for the next question, mass of the pan reason. So for mass, we need to select the mass which has smaller. So because we need have the lighter pan, right? So that we can easy to carry. So the answer, low mass, and the reason will be lighter, or you can mention as easy to carry. Both is acceptable. So 2 marks given, that means 1 mark for mass of material selected. So the second is the reason. So we go for question C. The pan is heated by using a 500 watt electric heater plate. Based on the information in table 2, calculate the time taken to increase the temperature by 50 degrees Celsius for the first one is pan. So the question asks about time taken. So we have given the example how to relate the time and power to energy in the previous video clip. So that means the formula is PT equal to MC theta. So P is power. So you can see PT equal to MC theta is the formula we use. So P is referring to power, which is given as 500 watt. T is what the question asks us to calculate. M is the mass of the material. We need to referring to the table. If not mistaken, just now we see is about 300 gram for all, right? So we can confirm again later. And then the temperature changes is 50. So that means all value we can get, and we just substitute into the formula. So look at the table 2. We go to table 2. Okay, so this is the table. Okay, so the mass for the copper is 2.2. The metal here actually is iron. Okay, so iron is 2.5 and the aluminum is 2.9. Okay, so the first one is copper. So we take the mass as 2.2 and the specific capacity is 387. Okay, so we get the value from the figure for the table 2, which the copper with mass of 2.2 and the specific capacity is 387. Okay, and the temperature changes is referring to this question, which is 50, and the power given is 500. So press with calculator, you will get the value is 85.14 seconds. Okay, so that means this is the time taken to let the copper pan achieve 50 degrees Celsius. Okay. Okay, so for the second one is the metal pan. So the metal pan is about 2.5 kilogram for the mass and the specific capacity is about 500. Okay, so same formula, we just substitute mass with 2.5, specific capacity with 500, and the 50 degrees Celsius given by question C, and the 500 watt is also given. So we substitute into the formula and we press calculator, we get 125. And the last one is referring to aluminium. Okay, aluminium. So we look at the table 2 again. So the mass is 2.9 and the specific capacity is 900. Okay, so with same way, so we substitute mass 2.9, specific capacity 900, and then the value of temperature is 50 and the power is 500. Okay, so we get 261. So as per expected, as the value of specific heat capacity is bigger, okay, so the material will take longer time to become hotter. Okay, so that means here the shortest time to achieve the temperature we needed is copper pan, as it has the smallest specific capacity. Okay, so which pan is more suitable for frying cracker in the short time. Okay, so referring to calculation from question C, we are surely that the answer is copper. Okay, which is only using 85.14 seconds. Okay, so let us go to the section B, paper 2. Okay, so this will be the last question in our discussion today. Okay, so diagram 1A shows a woman holding the handle of a hot cooking pot. 1B shows another woman holding the base of the hot cooking pot. Okay, so both women, okay, holding the cooking pot, but diagram 1A, the woman holding the handle. Okay, while for the woman in figure 1B, she is holding the base. Okay, so the first question is normally asking the definition. Okay, so here also same. Okay, so asking the definition of the statement of copper, which has a specific heat capacity of 400 joule per kg per degree Celsius. So that means the copper, okay, so need 400 joule of heat energy to increase 1 kg of copper by increasing 1 degree Celsius. Okay, you must including the mass and the temperature in your definition. Okay, so you can referring to the units. Okay, so let us see the answer together. Okay, so quantity of heat energy that needed to increase 1 kg of copper by 1 degree Celsius is 400 joule. Okay. So B, explain why the woman in diagram 2A can hold the pot safely, but the woman in diagram 2B actually is 1A and 1B. Okay. So diagram 1B cannot hold the base of the pot safely. Okay. So here 4 marks. So the first, the woman holding the handle. So the handle normally made out by material with higher specific heat capacity. This is the first mark. So material with higher specific heat capacity will heat slower. Okay, we heat slower or increase temperature in longer time. Okay. So this is the second mark regarding the picture 1A. Okay. So another 2 mark will be about the diagram 1B. Okay. So the woman hand holding the base part of the cooking pot. So the base part of the cooking pot is normally made up of smaller specific heat capacity material. So it will be increased temperature quickly, or you can mention become hot quickly. Okay, so this will be 4 marks. So let us see the answer together. Okay, so the first, as mentioned, handle of the pot is made up of material with high specific heat capacity, so that the handle will not easily to get hot or the temperature is low. Okay, so this is the second mark. So here is 2 marks for the explanation for 1A, diagram 1A. So second, it will be body parts of the pot. Here is actually the base. Okay, so base or body both also made up by the material with lower specific capacity, so that the body of the pot will get hot quickly, so that the temperature is high. Okay, so you will get total 4 marks for the answer. Okay, so now let us go to question C. So diagram 2 below shows the hot plate used to cook food. Okay, so for cooking food, we need material which given shorter time to cook. Okay, so we need to select the material with smaller specific heat capacity. Okay. Okay, so table 3 below show the characteristic of 4 pieces of metal plates. Okay, so here we have PQRS. The first character we discussed is regarding the density. So the density, we need to choose the low density or low mass lah. Okay, low mass material, because low mass material will be lighter, so that we can easily to handle. Okay, easy to carry. So here we can choose material Q or R. Both of these is lower compared to P and S. This is what we expected. Okay, so the second, we have to choose material with high melting point. Okay, so that the material will be not melt at higher temperature. Okay, so here we have to choose higher boiling point. So Q showing lowest temperature, so that means Q will be out already. Okay, so here we will select R or S. However, S given us a quite higher for density. Okay, so we see for the third character, specific capacity, which must be low, so that the food will be getting hot quickly. Okay, so we have to choose lower specific capacity. So that means S also is not suitable, so we are quite sure the suitable metal plate will be R. Okay, so the last one, rusting effect must be low, so that the pan will not become rusting so so fast. Okay, so I think the best material, okay, metal plate will be all which we choose is low density, so that the plate will be lighter, easy to carry. Okay, so this is the first. And the second, we have to choose the higher melting point, okay, so that the metal plate will not easily to melt at high temperature. Okay, so the third character we select is the low specific capacity, so that the food can become hot quickly. Okay, and the last one is the rusting effect must be low. Okay, must be low, so that the metal plate will not be rust easily. So we choose metal plate R. So let me show you the answer in table. Okay, so as mentioned, first we need to select the material with low density, reason is lighter, or you can write as easy to carry. Okay, so high melting point, so that the pan will not easily to melt at high temperature. So we select low specific heat capacity because the food will be get hot faster, and the low rate of rusting. Okay, so not easily to get rust. Okay, so the spelling is wrong here, R-U-S-T. Okay, so R is chosen, and we just copy back all the character mentioned. The first, low density; second, high melting point; and low specific capacity; and last, low rate of rusting. So you will get fully 10 marks for this section. Okay. Okay, so D, a solid material of mass with 0.5 kg is heated using 50-watt soaking heater. So the graph below shows the heating curve of the material. Okay, so here, what is the melting point of the material? So you may see that the temperature, the curve, okay, so it's increased from 32 to 77, and then the curve is stable, and then increase again, and stable again. Okay, so for melting point will be the curve from 32 to 77 is considered as solid. Okay, and start to melt at temperature of 77. Okay, so the melting point will be 77. Okay, so we go to our last question in our discussion today. Okay, so calculate the specific heat capacity of the solid material. Okay, so solid material is between 0 to 3 minutes. Okay, so the curve showing that the changes of temperature is from 32 to 77. Okay, so specific heat capacity, the formula we're using is Q equal to MRC. Sorry, Q equal to MC data. Okay, MC data. So, and question given us the power is 50, and the time taken is 3 minutes. So we can using the formula Q equal to PT to get the value of Q. Okay, and then we divide with M data. Okay, so we substitute all the value for P, question given 50, time taken 3 minutes, change to SI unit will be times 60. Okay, and the mass is 0.5, and the temperature changes is from 32 to 77. Okay, so we substitute all the value, we get the specific capacity for the solid material be 400 joule per kg per degree Celsius. Okay, so that's all for the discussion regarding the section 4.2 specific heat capacity today. Okay, so I hope that my video clip may help you more understand and know the technique to answering the paper 2. See you next time.
In next video clip, I will discuss with you Chapter 4 Heats, Subtopic, Section 4.3, Specific Latent Heat. Stay tuned.